we've got Azin, who is applied research scientist from Georgian. We've got Sarah, who is the director and model owner secured and small business decisioning at Scotiabank. We've got Asmita, senior data scientist from Microsoft, and Sedef, who is the director of professional development at Vector Institute. And the whole goal of this panel is to look at the different ways that engineers and data scientists can work together more cohesively, more harmoniously, because, and I encourage all of you right now, just so we can get like a pulse check, in the app that we're using, the WOVA app, I threw in there a poll, and it is Jupyter Notebooks in production, question mark. Feel free to answer what you think on that. I gave as many different ideas as I could, and we all know that is probably the hottest topic, and there are some very strong opinions. So it's good. I also will say this before we get into the meat and bones of the panel. It's good to like see people in person, because normally I'm doing this, as I said, on the internet, and I don't know if people are laughing at my jokes, and now I get to see that I'm not as funny as I thought I was. So let's get into it. The first question I've got for the panel, and I'm going to single out you first, Sedef. Let's just go over what are some differences between the working styles of engineers and data scientists. What are some things that we need to be mindful of?
Yes, everybody can hear me? Yes, that's good. So that's a great question. Thanks, Dimitros. So we need to think about like their working style. It's not too much of an issue, but their skill sets are much of an we need to be careful about. So one, the data scientists they are curious, and then they need to a lot of time to go into the details of the data, and they need more time to thinking very curiously. Whereas the machine learning engineers, so they are very systemic persons, so they need to design systems, so they need to have like a design thinking. So when we think about those two different skill sets together, so one is like a curious and then needs time, whereas the engineers needs everything's ready, and then they need to get things going from end to end. So when we are thinking about those two, so we need to make sure that their skill sets are different and they need different times. So the data science, again, like a lot of time, and they're curious, and they need like a little bit of maybe like a stakeholder. They need to work with like stakeholders. They need to understand the problem. So then they need to go back and then look at the data. Whereas the engineers, so they need to work with the data scientists. They also need to know the problem, but they have very little time to design the system end to end. So we need to be mindful of that one.
Yeah, it echoes a lot of what I've heard before, where you want to just iterate as a data scientist. I mean, it is science, so you want to go and explore, you have hypotheses, you want to see what's happening out there, see if you can test some assumptions, but then at some point you need to produce it, and you want to think about best coding practices and production code kind of stuff. Azin, did you have any other thoughts?
Sure. Just adding to what Sedef mentioned, I felt like from my experience working with engineers and data scientists, the biggest difference is in terms of their working styles. Engineers usually prefer to have a lot of clarity and certainty when it comes to the sprint planning and things like that. Whereas for data scientists, even if they prefer it, it's actually not, I would say, that possible. So, and I usually, the best data scientists that I know, they're people who are very comfortable with dealing, with uncertainty and ambiguity when it comes to the day-to-day job. So one thing that I have seen sort of to work well, considering these differences, is that, in different teams, people try to separate the engineering work from the data science work by introducing a common interface early on in the project, so that engineers get that sort of certainty, and like they know what they're expecting, and under the hood data scientists can work and have their iterations and do their experimentation. And it also applies to their sort of like planning, also to the planning. So, for example, in our organization, for the engineering workflows, we follow two weeks of sprints that are, there's more certainty involved. People know what they need to accomplish exactly by the end of the 2 weeks. But for the data science workflow, we sort of follow this idea of iterations, where the idea of iteration is that you have a hypothesis that you wanted to test, but you're not saying for sure that it's gonna be done in a day, so it's more flexible, and it allows for that sort of like uncertainty and flexibility when it comes to the day-to-day job.
Yes, I love that idea of just being a little bit flexible. I want to ask you all, like, do you use sprints for your data scientists? Do we get thumbs up, thumbs down? Yeah? And is it working? That's the big question, I guess. That's the follow-up one that we probably need more time to go into.
It depends on the project, though, and then depends on how long is the sprint. Sprint can be 3 months, sprint can be 2 weeks. So
there we go.
Maybe, sorry, just to add another point. I think sprints can also work perfectly for data scientists, as long as the goal is not to reach certain level of accuracy by, say, end of this week. I feel like as long as the task can sort of represent that uncertainty, if it's just like for the hypothesis testing, we're going to experiment with A, B, and C to see if we get to this goal by end of like this week. Something that's measurable and that sort of like accounts for that uncertainty. I think that also can work perfectly.
Excellent. Great points being shared here. Now, Sarah has a bit of a hot take, and I want to ask you, Sarah, what are some common challenges you face that cause data science plus engineering frustration?
And we're going completely unscripted, all real here?
Yes. Please.
Okay, so I have 2 hot takes, actually. Dimitrios only knows one of them, so I gave him a little bit of a preview. In my experience, and I was, trained as a data scientist, so I can say this with some level of certainty, data scientists are some of the snobbiest people I've ever met. They are wildly like, oh, you don't understand. There's like statistics back here. I have a stats major. Yes, guess what? You can teach stats to other people. It's wild. They're the same kind of people who are like, hey, you can't be a data scientist unless you have a PhD and you've done all this research in XYZ. Guess what? Some of the best data scientists I know do not have PhDs. They don't even have master's degrees. Some of them barely have undergraduates because they were terrible students, but they're passionate about data science. On the flip side, data engineers are actually some of the most arrogant people that I've met as well. And so, especially when like salaries started skyrocketing and every kid with an idea in a basement was getting $100 million to fund a startup, and then all of a sudden they're just like, well, I'm the foundations and I'm the architect, so like what can you do without me? Well, what can you do without a data scientist? So you can't do anything without the 2 of them cooperating from day one and like breaking down some of these weird barriers. I don't know if it's human nature, but we like to pit each other against it. It could be like Waterloo versus U of T, Silicon Valley versus the MIT of Canada, or like even within universities, if there's anyone who is from the University of Waterloo, that's my alma mater. It's like engineering versus math, and it's like, no, it doesn't. We're all solving problems, and we're all solving this together, and we can't do anything without it. So I think if we kind of take our heads out of our asses and just work together and start communicating openly from day one, and not just like work in silos and not just show up on someone's step and be like, hey, I built a model, I need you to implement this tomorrow, or vice versa, being like, hey, you're pulling data from places I can't productionize. Like, there needs to be communications from day one.
So you went a little harder than I thought. Yeah, give it up.
You asked for it.
Wow.
I mean.
All right. I'm still waiting for the tooling company to come and say something like bridging the gap between your data scientists and data engineers.
Synergies.
I think that would be great. That would be hit right on the nose. Anyway, we've got Asmita who has some other thoughts on this.
So in my role, I work a lot with Microsoft customers. Like I'm on the field side of it. So I have seen like the journey of, like data engineers and data scientists. Like earlier, there used to be one person doing everything, but now there is a clear distinction between the teams. But as Sarah was saying that there is a lack of communication, I don't think it's because of like the individuals. It's sometimes because of the isolation of teams in the organization. Like there would be a whole org of data engineers and then would be another org of data scientists. And because of the ambiguity of the work, or there's like a lot of uncertainty in how much time is it going to take to solve the problem, I do feel that data scientist team gets treated with a lot of privilege, and you get very less access to those teams. So everybody is kind of, oh, can I get to work with that data scientist team? And then they would be like having a bunch of criteria to block the businesses. So I do feel that because of that, like there's always like these data engineers feel that, oh, we don't get that much importance. But I do feel like both the roles have equal importance in the organization. Nowadays, like when I work with a lot of our customers, I do feel like I work a lot with data engineers than data scientists till a certain point, because you need to have like data available, the data model should be there. There should be a amount of work that has to be done in terms of getting data like ready for the analysis, and then the data scientist will come in and then they will start working on it. So I do feel that it's changing. Also, I think people are making a lot of good career choices nowadays. Like they clearly understand the distinction between data engineer and data scientist, which was not there a couple of years back. So the industry is evolving, and I think the picture is changing now.
Yeah, that last point is so fundamental, and I think a lot of conferences like these are helping solidify what to expect from each role and how to look at these different roles. So I've got another one. There was from Azin talking about messy code, but I just wanted to share a story of when we were at the happy hour the other night, and that was, I was talking to Lynn, who I'm not sure is around here, maybe. He said he would come, but of course it's early, and I'll forgive him if he didn't. He was talking about how, for him, as a data scientist, he just wants to throw the model over the fence and never hear about it and just see what its performance is. And so I thought, this guy's crazy. What? I thought we got rid of that notion with DevOps and we don't need to do that anymore. And he was like, no, I don't care. Like, I don't want to see any of it. I just want to know how it's performing, and that's it. And then all the other like messy stuff, whatever. And then that's where the idea of Jupyter Notebooks in production came, because he was like, I asked him, I said, but how will they have any idea of what's going wrong, if something's going wrong, or how to fix anything? And he said, well, I'll give them the Jupyter Notebook. I was like, perfect, everything's settled. We're good then. That's your solution. So you've talked about messy code. Can you go into that a little bit more?
Into the messy code?
Yeah. And how that can be some friction points between engineers and data scientists.
I think that can be a friction point between anyone, to be honest. Like even between data scientists, I get messy codes sometimes from our collaborators, and as soon as I like open the notebook, I'm like, oh my god, am I supposed to understand it? How am I supposed to understand this? It's just like, I feel like I don't think there's anything wrong with Jupyter Notebooks. Even if you think about Jupyter Notebooks, there are best practices to make your notebook more readable, more understandable, sort of like decouple it and decompose it into different understandable modules. But my personal preference, obviously, when it goes to anything for production, is to stay away from Jupyter Notebooks. Just because there are like a lot of problems that I think everyone in this room are familiar with, like not having any order for running your comments and in your Jupyter Notebook, a lot of issues with setting and seed, yeah. So I feel like generally speaking, at least from our experiences and what we have done so far, anything that goes to production, we try to stay away from Jupyter Notebooks. I'm very, strong. Like I have a kind of a strong opinion on that end. Anything for exploration, we definitely try to stick with Jupyter Notebooks on the other side, just because it's very flexible. I mean, that sort of flexibility is a game changer when you wanted to run fast experiments and you're in a hackathon mode. But when you wanted to productionize things and you wanted to have something that's easily digestible by engineers, by other data scientists. That's, I think, the point that you should think, about moving away from Jupyter notebooks and trying to move and convert your code into Python scripts.
Yeah, how to come out of the notebooks. Did anyone, I see some microphones going to the face. What, give it to us, what do you got?
When it comes to messy code, I don't understand, because like, doesn't messy code come back to haunt you, like let alone anyone else? But like one day, you're forced to look at something and it's just wild, right? Like how many people, then you sit there and you look at it and you're like, what was I on for that day? It makes no sense, right? But I think like more importantly, like I'll retract that. There are industries that are incredibly highly regulated, right? Banking is one of them, healthcare is another, et cetera, et cetera. In highly regulated industries, guess what? The regulator can and will and does regularly walk in and look at your code. They actually look at your code and they run your models. And if they can't replicate anything, you're in a shit ton of trouble, right? Like that's how you get massive fines, et cetera, et cetera. And so there's like the regulatory component, but then there's also just like, what's the right thing to do, right? Like, why? Let's make things easier for, if not other people, at least like future you. Yeah. And then that ultimately ends up being the right thing for the customer down the line.
Oh, I love that.
I think here, I just want to add one thing. Going back to the messy code, okay, so we are human beings. So we, when we start, thinking about, so what I do usually, I scratch things up, just very quick and dirty. But when it comes to the application side, so again, like we're going to work with the machine learning engineers team, but the point is that we have to have a tool set at the beginning. So then all the data scientists and engineering team, they had to use the same tool set. So then we'll come to the standardization and all the codes and stuff. So I think it'll help a lot for the data science team as well as the machine learning engineering team. So I also teach data science and analytics program. So I always tell my students, so whatever you do, please document it. Document it how you do, document it what you did, and then go back to your documentation time to time, and then see how messy you were at the beginning, and then you have to correct it, right? So if you don't correct it, nobody will understand, nobody will reproduce your work. Yep. So it is also important for the teams, it is important for the research as well. Reproducing your code, reproducing your research, so then one can take and then advance it afterwards.
So let's go into this question now, change gears a little bit, which kind of touches on another one of the hot topics that comes up a lot, and it's should or can data scientists evolve into engineers? And I say it touches on the hot topic because there's a lot of controversy around if a data scientist should know Kubernetes. And you probably saw there was a Kubernetes workshop here, and maybe some of you are data scientists and you wanted to figure that out, and so you jump into it. Is that where they're going to add the most value, though? And if a data scientist is doing their thing and having success, should they then go and branch out and learn more? And I'll hit you with this one first, Sarah.
I think that data scientists are a dying breed. I do think at some point in time, and to some extent ML will too. Maybe, I think there's an idea that 30, 40 years from now, these ML ops programs are going to get stronger and better, right? So I think to be successful in any industry, any field, you need to be constantly evolving. And I think that means for data scientists, they have to understand what is going on at the production end. But there's benefits to this, right? Like the idea of being able to parallelize your model build so that you're not taking 6 days to build a model, you're taking a few hours, right? Like that requires some of these ML concepts that you can learn. You don't necessarily have to be the best one in the room. On the flip side, I do think ML engineers have to have a better idea of what it means to build a model, because there's some weird misperceptions that kind of can float around from that. I'm really happy, and we've alluded to it a few different times, that the industry has finally moved on from one size fits all, because the day when a data scientist was literally your miracle worker, that made no sense. And that's why so many data projects failed, is because you heaped all your dreams on a single person that wasn't able to do everything from end to end. And so we're never going back to that model, yes. That's for sure.
Hopefully not, yes, I agree with you on that one. Azin, did you have any thoughts?
Yeah, just echoing Sarah, I felt like Again, I am a believer in this concept of T-shaped learning. You need to specialize, really specialize in one area, but at the same time understand the other areas in a breadth. And considering that, I feel like data science is not different from that concept. You know, like for data scientists, you know, myself, I'm working on something that's sort of like aligned with my expertise. You know, ML experimentation, developing models, but at the same time, any chance I get, I try to understand about the ML ops, just because, as Sarah mentioned, it's helpful for ourselves. Like if I know how this model is going to be served at the end and what are going to be the constraints, I know if I can go with a bigger model or I should, you know, limit the size. What are the constraints? Can I change the interface of this model? Like just having that visibility and knowledge, it doesn't need to be deep, but if you just, you know, understand in high level what's happening before and after this model, like what are the steps before and after, you know, this model is developed, then you can do your job better. And I highly recommend that. Like, you know, that's what I aim for myself, just to follow that T-shaped learning moving forward.
Yeah, and Asmita, you've seen a lot of different companies. You've been able to get insight into different ways that teams are structured. And on one side, we have what I was talking about earlier, where you just throw something over the fence and the data scientist doesn't want to know anything about it. And then on the other side, you have almost like this, like blurred lines. Yeah. Have you seen one that works better than the other?
In my opinion, I think nowadays, like I'm a lot into this technology conversation with the data science team. Like even the managers or the VPs of this team, they are more interested in terms of how we can take these models to production. What is MLOps? MLOps is operationalizing the model. It means taking your model to market or to production. And how you would do it, like it's not possible to do it without the use of technology. And that's why it's very crucial for you to know, like, I know data science, I'm an applied data scientist, I'm more into technology side of it. So, like, I have to work throughout the day, like different technologies, like Kubernetes or being Azure, cloud, even like on some of the data technologies. So you need to understand, you know, like these lines or these boundaries of different technologies so that you would be able to use it wisely. If you do not understand it, then you are in a silo, like you are working on your own machine or your, like, you know, the small size VMs, and you're trying to do it and maybe it's not happening because you're not using the right tech for performing or training your models or operationalizing those models. So it's very necessary. I don't say that you have to be an expert in that, but I do believe that you should know it at least to the stage of, you know, using it at a beginner stage or how other people are going to operationalize your models. So at that stage, you should have an understanding or awareness of the different technologies that are required in the data science space.
And Sedef, I know that we talked a little bit about the idea of these different titles that you can get when it comes down to machine learning engineer and data scientist, data engineer. But if you look at the job description for each title, it can be wildly different. And I think you had some thoughts on that and how that can be remedied. I mean, I know that when you even just look within machine learning, let's play the game. Which one of these is not like the other? We've got robotics, we've got tabular data that you can use like you need it real time. We've got computer vision. There's all kinds of different ways that things can be used within machine learning. And so when you look at the different job descriptions for this, is machine learning engineer the right title or data scientist? And how do you think about those things?
That's a good question. So again, we are sticking with the titles, which is fine. But going back to the team. So again, like it depends on the company size. Like some companies are, you know, small and medium-sized companies. They don't have that much of a resources. They wanted to start from somewhere, and then they hire data scientists. And I've seen a lot of companies like that. And then they ask data scientists to do all the job, right, from the beginning to the end. And then the big enterprise companies, they have different teams, they have data scientists, and they have now realizing that the machine learning engineers they need to hire, and then they now putting those titles out there. So I think that's the also the HR issue as well. Like we need to work with the company's HRs, so to have like a clear definitions of the titles, clear definitions of the responsibilities, and then when we go out, release those jobs, so to make sure that those job responsibilities are very clear, there is no area of like a blur area or so when we talk about when we interviewing people, so then they can understand what we are looking for. So this is, I think, very important. So again, going back to the evolution, so from data scientists to ML engineers. So of course, like we are curious people as a data scientist. So we need to know what's happening after we handed over the code. So it doesn't mean that, oh, it works fine in my machine. So it doesn't work like that. Like most of the data scientists, they say, oh, it works fine in my time. So just hand it over to you. It doesn't, I don't bother whether it works on your side or not. But it doesn't work like that. So again, like the titles are okay, but we need to make sure that when we have those titles, we have those responsibilities. So we need to work with the team. We need to work with the HR. So then we can, create those titles.
Mm-hmm. And I've heard, actually, it's interesting you bring that up. I did not make this up, but I've heard something called a data scientist plus, someone that knows how to use Git and refactor their code and all that kind of stuff. It's like you get an extra bump there. So there's something really interesting because you look at when DevOps came about, DevOps was very much not just about tooling. There's this deep practice that comes with DevOps that is very much about cultural piece. And Asmita, I know you've seen different teams. Like, how have you seen the best teams interact when it comes to MLOps on the cultural side?
It's a challenge, I would say. Like we are still solving it. I'm working on something called data science as an app. So like viewing your data science project as application development, right? That's something I'm researching on right now and working with some of the app developers on our side. So I was a application developer myself, like first 4 years of my career is to build Java applications, web applications. So I understand that practices. As we were talking about messy code or standardized practices or like putting your code into like different phases of the build or production life cycle. So that needs to be defined. There needs to be like a process and the culture that has to be built. There are two different mindsets as well, right, as we are talking about it, and we need to bridge that gap because data scientists, I mean, you cannot push them to think creatively at the same time ask them to be within the boundaries. That's the challenge. So how you will manage that balance, that's a challenge for a lot of leaders right now, like how they are going to have that balance of data science and then taking what they need from these models and then pushing it over to the ML engineers or ops teams for operationalizing the models. So the culture change is happening. It's happening in, I think, depends on the size of the organization and also like the maturity of the data science in the organization, but we still have some time to be there, I feel.
Excellent. All right, so we've got to wrap up. If you all enjoyed this, I do it every week, and we have a podcast with the MLOps community. You can feel free to just look at your podcast app and find it if you type in mlops.community. I'm also on TikTok if you want me to you want to see more of the funny stuff that I do, you can find that. And I want to give a big round of applause and a huge thank you to all of our participants today. This was amazing. Thank you all, ladies.
Thank you.
Thank you.
All right, so hopefully now we've solved it. We're good now, right? No more problems. Enjoy the rest of the day.
Thank you.
Thanks, Dimitri.